So you just played a game and had the worst experience of your life. And you think to yourself, even I could create something better than this. So you open up Unity, create a project, and oh crap, you have no idea how to even get started. When it comes to game development, one of the first things you will need to create is a character controller. It's the foundation for how your player interacts with the game world, controlling the movement, camera, and responding to physics or collisions. Without it, you can't properly test environments, gameplay mechanics, or animations since the player won't have a functional way to navigate or interact with the game. Also, how can the player explore fascinating bugs like this without it? In this video, I'll be showing you how to create a custom character controller by covering 4 key topics, which are Cinemachine, cross-platform input support, Animator, and controller scripting. Just as a quick heads up, I'll be demonstrating everything by creating a single-player third-person game. Keep in mind that the requirements for each topic listed may vary depending on the type of game that you're working on. So if there's some other game type you'd like me to cover in a future video, be sure to subscribe and let me know in the comments down below. My name is Esper, I work as a freelance game developer and I'm also a Unity asset publisher. My goal is to create assets that empower passionate indie game developers to help bring their dream games to life. All of my assets are available in the Unity Asset Store. A link will be in the description below. Some of my assets are even free, so even if you'd prefer to not pay anything, it's worth it to check them out. However, I'd highly recommend checking out my paid assets as they are either much easier to use, packed with more features, or both. By the way, I've recently decided to try out content creation. This is my first real video ever, so I'd appreciate any feedback, positive or negative. Now let's get on with the video. So you find yourself in this gray landscape, unsure of what to do. First of all, to create a 3D third-person game, you're going to need a rigged 3D model that represents the player character, and also basic movement animations like walking, running, jumping, falling, and landing. I'm going to be using this little robot I had lying around along with animations from Unity starter assets. If you don't have a model, you can find free ones on the asset store, or you can create your own if you happen to have such a skill set. I'll leave a link to Unity starter assets, which comes with a free 3D model and has all the animations we're going to need. You can also try browsing Mixamo as it has a lot of free ready-to-use animations. Unity starter assets includes a third-person controller, so you might be wondering, why build our own from scratch when we could just use that? The answer is simple. You won't truly learn how it works otherwise. This tutorial is designed to give you a deeper understanding of the underlying systems, which will hopefully allow you to customize your character controller for your needs. Once you have your model and animations ready, the next thing we need is to install the required packages that we will be using to develop our game. We're going to need 2 essential packages: Cinemachine to effortlessly make the camera follow the player's movement, and the input system to simplify adding cross-platform input support. You can ignore this part if you already have these packages installed. For those that don't, navigate to Window, Package Management, Package Manager, click on Unity Registry and search for Cinemachine and click Install. It may take a minute. After that's completed, search for Input System and click Install. You'll be prompted to restart the Unity editor. Click Yes and wait for it to complete. Once that's done, we can move on to the next step. At this point, we should have everything we need to get started. Let's set up our scene by simply adding a plane that will serve as the floor that our player character will be able to walk on. Scale it up so that there's plenty of room. I'm actually going to add a material I had lying around just to make it look a little better. You can just skip this part. Now we can drag and drop our player character model onto the scene. And there we go, we are ready to move on to one of the main components that will help bring your game to life, which is Cinemachine. We're going to set up Cinemachine to simply make our camera follow the player. The first step is to create a new game object as a child of your player character. Let's call it Camera Target. Move this object to around the neck area of your character. Next, right-click in the hierarchy, navigate to Cinemachine and click Cinemachine Camera. This will add Cinemachine into your scene. Click on Cinemachine Camera and set the lens to 40 from the inspector. This is just a personal preference, honestly. After that, set the tracking target to the camera target game object you created. Also, set position control to third-person follow. Set the shoulder values to 0, and now you should be able to see the back of your player character properly through game view. It may not be perfect, so we can adjust the camera distance value. Also, I highly recommend enabling avoid obstacles. Leave the collision filter on default, but enable ignore tag and set it to player. Click on your player character and set their tag to player. I'd recommend setting their layer to player as well. If you don't have one, you can simply create it. Our camera is now set to follow the player character. To test it, enter play mode and adjust the player's position through the transform component. You'll see that no matter where you move the player, the camera stays locked on. And that's it. That's all you really need to do to set up Cinemachine. Now, obviously we need our character to be able to move around with input. This will be done when we get to the scripting section of the video. Right now, we should just decide on our input controls. So we are going to be adding cross-platform input support, which essentially means that the game will support multiple input devices. We're going to be targeting keyboard and mouse, as well as every controller. We're actually going to skip mobile controls in this video, as that requires a different setup with UI buttons. So right-click in the project section, navigate to Create, and click Input Actions. This will create an asset that will help us set our input keys. Let's just call it Input Actions. Double-click it to open it. Create a new action map. Let's call it Controls. Now we're going to add 4 actions: Move, Jump, Run, and Look. So let's ensure we have 4 actions in this map by clicking on the little plus sign here. And now let's rename them accordingly. By the way, be sure to toggle on autosave from the top right. Click on Move, set the action type to Value and the control type to Vector2. Click on Run, click this little plus sign beside Interactions, select Press, then set the trigger behavior to Press and Release. Press and Release will trigger the input key when the button is held down and when it's released. Delete the binding under Move. Click this little plus sign and then select Add Up Down Left Right Composite. Rename 2D Vector to WASD, which will be our input keybinds for a keyboard. Set the keys by selecting each one by one and then selecting the path and searching for the specific keybind. Up will be W, down will be S, left will be A, and right will be D. This time add a regular binding and set the path to left stick gamepad. This will allow us to move our player with a controller by using the left joystick. Now let's move on to the jump keybinds. We're going to set the first one to spacebar, then add another binding, and set it to the south button on a gamepad. This would be the A button on an Xbox controller or the X button on a PlayStation controller. For run, we're going to use left shift for keyboards and left joystick press for controllers. Now for look, set the action type to value and control type to vector2. Then set the first binding to mouse delta and the second to right stick. And that's it, our keybinds have been set. However, they won't work until we create the character controller. Before we move on, let's give our player the player input component and set the actions field to our input actions asset. Now let's move on to the animator. I have a bunch of animations here. These are just taken from Unity starter assets. I'm going to be showing you how to create an animator controller. Right click in the project section, navigate to create, animation, and select animator controller. You can name it whatever you'd like. I'll just call it player animator. Double click it to open it in the animator editor window. Unity's animator window is where you can create and manage an animator controller, a state machine that controls how animations play on a game object. You can add animation states and create transitions between states so your character or object can smoothly switch between different animations based on game logic or player input. So we have walk, run, jump, fall, and also land animations, and we need these to play at the right time. So we'll start by creating some parameters. a float parameter called speed, a trigger parameter called jump, a bool parameter called falling, and another bool called grounded. We will be using these parameters to transition between states at the right time. So let's create our first animation state. Right-click on an empty space, go to Create State, and click from New Blend Tree. Now rename this to Idle Walk Run Blend. You will see the blend tree in the motion field in the inspector. Double-click it so that we can start making edits. A blend tree is a special animator state that blends between multiple animations based on a value of a parameter. So we're going to add 3 motions by clicking the little plus sign. Set your animations in the fields by selecting the circle icon and looking for it. The first one should be idle, next one should be walk, and the third one should be run. So now these 3 animations will blend based on our speed value, which you can see it's already set at the top here. And now all we need to do is add our jump animation states. So let's add 2 regular states and name them jump and fall. Set the appropriate animations for each state. These are not blend trees, so you could just set the animation right from the motion field. Finally, let's create another blend tree state. Rename it to land blend. Similarly to idle walk run blend, we're going to be blending our land, walk land, and run land animations with the speed parameter. If you only have one landing animation instead of a blend tree, you could just create a regular state instead. Now we just need to set up our transitions. To create a transition, you simply need to right-click on any state, select Make Transition, and then select the state you'd like it to transition to. The first transition we created is from Idle Walk Run Blend to Jump because the player should only be able to jump while grounded. Select the transition and from the bottom of the inspector add a transition condition and set it to Jump. Also, this transition does not need an exit time, so disable it. Exit time is just a fixed value that allows a certain amount of the current animation to play before transitioning to the next. The next transition we're going to add is from Idle Walk Run Blend to Fall, because technically the player doesn't need to jump to start falling. They could just fall off a ledge or something. Select the transition and add a condition which requires the fall parameter to equal true. This transition does not need an exit time. Next, we're going to add a transition from fall to land blend. This one will have grounded as its condition because the land animation should only play when the player has landed on the ground. Again, this transition does not need an exit time. And now we're going to add 2 conditionless transitions, from jump to fall and from land blend to idle walk run blend. These ones don't need conditions because they just need to transition to the next animation when the previous ones are complete. At this point, we have completed the animator controller. Now all we have to do is give our player object this animator. Now that we have everything ready to go, we can start scripting our character controller. Let's start by adding some components that we will be working with. Click on your player character, click Add Component, search for Capsule Collider and click it. Then click on this Edit Collider button and adjust the collider to match the size of your character model. The next component we need to add is Rigid Body. Add it the same way you did before, and just set the interpolate field to interpolate. We're going to add one more thing, the character controller, but first we need to create it. Right-click in a blank space in the project section and navigate to Create, Scripting, and click Mono Behavior Script. Rename it to Third Person Controller. Now you can double-click to open the script. However, you might need an IDE. An IDE, an Integrated Development Environment, is a software application that provides the tools you need to write, edit, debug, and manage code all in one place. Personally, I use Visual Studio. I'll have a link to it down in the description below. You can use the IDE of your choice. Technically, you could just use Notepad, but an IDE is recommended. Once you do install your IDE, go to Edit, Preferences, External Tools, and set the external script editor to your IDE. Now double-clicking the script will open it in your preferred IDE. Also, don't worry if you don't know anything about coding, I'll be explaining a lot. So right off the bat, we have a class called the third-person controller that inherits from the monoBehavior class. If you don't know what a class is, it's basically a blueprint in programming that defines the data and behaviors an object can have. Any class that inherits from monoBehavior will act as a component that can be added to game objects. So if we switch over to Unity, we can actually add this script to our player character. But of course, it doesn't do anything at the time, so let's start coding. Switch back to your IDE and let's remove this code here since we don't need it at the time. Remember to use Ctrl S to save your changes. The first thing we're going to add is input detection. So how do we do that? Well, on your player input component, notice how it says it will send messages named onMove, onJump, onRun, and onLook. Remember, we created input actions called move, jump, run, and look when we were editing our input actions asset. The player input component just adds the on prefix as part of the naming convention. But essentially, if we add methods in our script with these exact names, they will be called automatically when our specific input buttons are pressed. If you don't know what a method is, it's basically just a block of code inside a class that performs a specific task. First, we need to add some fields that the methods will be using. A field is just a container that stores a specific data type. Let's start by adding a private vector2 called move. Private just means that this field can only be accessed by this class. Public would mean that other classes can access it as well. Vector2 is just a group of two numbers. This will store the movement input. Create another field called isRunning. This will be bool, meaning it can only be true or false. Now let's start creating our input methods. Write private void onMove and pass an input value parameter. A method parameter just allows you to send specific data to the method which it can use to perform its task. The input system automatically sends the input value. Inside the method, we'll just get the movement input as a vector2 and store it in our move field. So now we're just going to create the remaining input methods. The next one is onJump. This is simply going to call another method called jump, which we will work on later. Now create a method called onRun and pass an input value parameter. Inside it, simply make isRunning equal to input value.isPressed. So if the button is held down, the player is running. If not, then the player is walking. Finally, create a method called onLook. This one will be similar to onMove, so let's add another vector2 field called look. Inside the method, we'll just get the look input and store it in our look field. And that's all we have to do for input detection. So now we're going to add some fields that will be visible in the inspector while also stylizing our component a bit. A header is just a title for fields. A serialized field makes private fields visible in the inspector. Let's add a transform field called grounded checkpoint. This will be used as the center point of our grounded check logic. It will be relative to the player's position. Also, let's add another header for the Cinemachine field, and let's make sure we can reference the camera target object. Switch back to Unity. As you can see, our fields are visible in the inspector. Let's create our grounded check object, which has to be a child of our player character. Drag and drop both the camera target and grounded check to the appropriate fields. Add two more fields, one float that will serve as the radius of the grounded check. and a layer mask that will let us set which layers count as the ground. Switch over to Unity and set default as the ground layer. Great, now let's finish up our grounded logic. Create a method called groundedCheck. Add a bool field called isGrounded and set its default value to true since our player starts off grounded. Inside the groundedCheck method, we'll make isGrounded equal to a physics sphere cast that essentially checks if a sphere the size of ground check radius at the grounded checkpoint collides with any ground layered object. We can visualize this sphere by adding some gizmo logic. This is optional but very helpful. So what we're doing here is just utilizing Unity's gizmo system and drawing a sphere based on our fields that will be visible in scene view. Now if you switch to Unity, you'll see a sphere at the grounded checkpoint. So we're still missing one thing. We have to let the animator know that the player has become grounded. We can do this by updating the specific parameter we created on our animator. Let's add some const string fields that match the names of our parameters. The const keyword just prevents the values from being changed from their default values. And a string is just a data type that contains text. Also, let's add a rigid body and animator fields that we will use later on. Now create a method called awake. Awake is a Unity message and it's called automatically when the script instance is being loaded. Awake is usually where you want to set component fields, as I did here with getComponent. Now in the groundedCheck method, we can just do animator.setBool, reference the grounded const, and then pass the isGrounded value to update the grounded parameter on the animator. And that's all for our groundedCheck logic. So now let's just add our move and look methods that we'll be working on later. Alright, before we get to those, we'll do jump first because the logic is much simpler. Add a bool field called canJump and set it to true. Create a new header for jump and create two float fields, one for jump strength and another for jump downtime. I'll just set the default jump strength to 7 and the default downtime to 1. In the jump method, we want to disallow jumping if the player is not grounded or the player cannot jump due to the jump downtime being active, which is what this if statement does. Return just simply makes the code process end there. Below that, we can add our jump logic. We can do this by simply adding upward force to the rigid body. We'll multiply it by jump strength so that we have control over it. Since the player has jumped at this point, make canJump equal false. Also, we need to trigger the jump parameter on the animator. So now we'll implement the jump downtime with a coroutine. If you don't know what a coroutine is, it's basically a method that allows you to set delays to code execution. By the way, ensure you're using all these namespaces listed here. So first, it starts off with a small delay to wait for the player to be a decent distance off the ground. Then we wait for the player to be grounded once again. And finally, we wait for the jump downtime before allowing the player to be able to jump once again. This coroutine should begin when the player jumps, so let's add it here in our jump method. And that's all for our jump logic. So now let's implement looking around. We're going to need to add a few more fields here. Create float fields called yaw and pitch. These will keep track of where your camera is facing. Yaw is for left and right, while pitch is for up and down. Add 2 more fields under the Cinemachine header. The first one is top clamp, set it to 70. The second one is bottom clamp, set it to -30. These 2 fields are angle limits for how far the camera can tilt up or down. Add a const float field called look threshold and set it to 0.01. We will use this to disallow very tiny accidental movements or to prevent jitter from micro movements or hardware noise. Now in our look method. First, let's check if there's any meaningful input. If so, we'll calculate how much to rotate this frame. And I just realized I forgot about the speed fields, so let's add them real quick. Create a new header for speed and add a float field called look speed. Set it to 10. So yeah, we calculate how much to rotate this frame with our look speed field. And then we apply horizontal and vertical camera movement. Before we continue, let's create a new method that will clamp angles within a given range. First, we ensure that a given angle is not below a -360 or over +360. And then we clamp it within a given range and return it. Now we can use this to clamp both the yaw and pitch. We'll just clamp yaw with the max float and min float values. We can clamp pitch using the bottom clamp and top clamp fields we created earlier. And finally, we can set the new rotation on the camera target object. Whoops, this needs to be rotation, not position. We're finally getting near the end. All we have left is the move method. Let's start by adding the necessary fields. Under speed, create a float called movement speed. Also, create another float field here called current speed. This will represent the player's current movement speed. It will start at 0 and quickly ramp up over time until it reaches the maximum value defined by movement speed. This creates a smoother, more natural acceleration effect instead of the player instantly moving at full speed. Let's start off the move method by finding the target speed. If the player is running, the target speed will be double the movement speed. Otherwise, it will just be the original movement speed value. We have to multiply this by the magnitude of the move vector so that diagonal movement is not faster than straight movement. And now let's linearly interpolate between current speed and target speed over time. Multiply by 8 here to make this reach the max value fairly quickly. Here we're just grabbing the forward and right movements. And now make sure the Y value is not included because we don't need it. Also normalize the vector so that they are a length of 1. Now let's calculate the move direction by multiplying the forward and right values with the move input. Also, normalize it to ensure diagonal movement is not faster. Create an if statement that prevents tiny unwanted movement inputs. Here we will rotate the character towards the movement direction. First, let's find the target rotation based on the move direction. And now let's quickly, spherically, interpolate towards the target rotation. So first, let's grab the current velocity. And here we multiply the movement direction with movement speed, while ensuring the y velocity is untouched since we want the built-in gravity to handle it, while applying it to the rigid body at the same time. Let's add an else statement here, which will be executed if there's no movement, so we can just set the velocity to 0 while keeping the y velocity untouched. We still need to update the animator, so let's calculate the normalized speed because the speed on the animator's end has to be a maximum of 1 with the way we have it set up. And now we can set the speed parameter on the animator. And we also want to set the falling parameter. The player is considered to be falling if they are not grounded and the rigid body's linear velocity is less than -0.1. At this point, we've completed our methods. However, some of these methods should be running every frame. Unity has special methods for this, and we're going to be utilizing all of them. Simply add update, late update, and fixed update methods. We'll call our grounded check method an update, look and late update, and move and fixed update. These update methods are automatically called by Unity at slightly different timings. We want our grounded check to occur immediately, which is why it's an update. We want movement to finish first before updating our rotation, which is why look is in late update. Fixed update is synchronized with the physics system, which is why it's best to put move there. At this point, we're officially done coding our character controller. All we have left is testing. But before I forget, make sure to freeze rotations on our player's rigid body. Now we can safely enter play mode and test our controller. Alright, it works. However, I am noticing an issue with the jump animation transitions, so I'm just gonna fix that real quick. Okay, that looks pretty good. Remember, you can fine-tune things yourself as you'd like. Anyway, I hope I've helped you learn some basics of Unity game development. If you have any questions or you'd like to see me tackle a different topic in the future, leave a comment below. If you found this video helpful, give it a thumbs up, and subscribe if you'd like to see me make more videos like this. Also, I recommend checking out my latest asset, FeelSpeak. It's a node-based dialogue system that makes it incredibly easy to make your characters express emotions during dialogue. That's all from me for now. Will I see you in the next video? I don't know. You tell me.